Miguel Ramirez, and I'm the leader of Group 5. Now we will talk about converting normal to normal standard distribution and vice versa. So what is standard normal distribution? The standard normal distribution is a special case of distribution in a normal distribution. It is the distribution that occurs when the random variable z has a mean of 0 and a standard deviation of 1.
Hello everyone, my name is Sean Andre Sabino, and today I will be discussing about how to get the C-scores. Problem number 1. The scores of STEM 1 students in the final examination for general mathematics has a mean of 32 and a standard deviation of 5. Find the C-scores of the following raw scores. The raw scores are 37 and 33. Here is the formula for the C-score. C is equal to X, or the raw score, minus mu, or the mean, over sigma, or the standard deviation. Now let's substitute the value. C is equal to 37 minus 32, which is the mean, over sigma, or the standard deviation, 5. First, we must subtract the raw score and the mean before dividing with the standard deviation. 37 minus 32 is equals to 5. Copy the denominator and divide. It is equal to 1. Therefore, the C-score of A is equals to 1. Now let's proceed on getting the C-score for B. The raw score, X, is equal to 33 divided by the mean, subtract 32, over sigma, or the standard deviation, which is 5. First, as I've said before, we must subtract before dividing. 33 minus 32 is equals to 1, and copy the denominator. Next is that we will convert the answer to decimal. Therefore, the answer will be 0.2. Therefore, the answer for B is the 0.2.
I am Liam Mangayindan, and I am going to discuss normal distribution.
Normal standard distribution can be transformed to standard normal distribution by the formula G equals X minus mu all over sigma, where X is score, mu is mean, and sigma is standard deviation. Each of the values obtained using the given formula is called Z-score. The standard score, or Z-score, is a measure of relative standing. It represents the distance between a given measurement X and the mean, expressed in standard deviations. For any population, the mean and the standard deviation are fixed. Thus, the Z formula matches the Z values 1 to 1 with the X values. That is, for every X value there corresponds a Z value, and for each Z value there is exactly one X value. Example, in a given normal distribution, the sample mean 20.5 and the sample standard deviation is 5.4. Find the corresponding standard score of 18. Standard score is equals to 18. Sample mean is equals to 20.5. Standard deviation is equals to 5.4. Z is equals to X minus sample mean all over standard deviation, which then equals to 18 minus 20.5 all over 5.4 equals to negative 2.5 over 5.4, which then equals to negative 0.46.
Good morning everyone, my name is Shed Lowell M. Sandoval. So for today, I will discuss how to convert from standard scores to normal random variables. So here is the example. A highly selective university only admits the top 5% of the total examines in their entrance exam. The results of this year entrance exam follow a normal distribution with a mean of 285 and a standard deviation of 12. What is the least score of an examine who can be admitted to the university? So here is the solution. Look at the Z table and find a value of 0.95. This means that 0.05 or 5% are above this from the table. The value that is nearest to 0.95 is 0.9505, correspondence to 1.65, intersection of 1.6 and 0.5. The z-score 1.65 has an area of an 0.9505. So the x is 285 plus 1.65 times 12. The final answer is 300. 304.8 is equals to 305.
Hi, I'm Lance Lumatap and I'm gonna give you another example.
The first thing that we need to do is to graph. Based on the example, we have a mean of 80 with the intervals of 10 because our standard deviation is 10. So this will be our graph. The question is, how many percent of students got below 81? So on our graph, this part of the graph is what we are talking about. So by solving this, we're going to use the standardization formula, which is z is equal to x minus the mean over the standard deviation. We're just distributing the values to the equation. So z is equal to 81 minus 80 over 10, which gives us an answer of 0.1. Now, by looking at the z-score table, 0.1 is equivalent to 0.5398. Therefore, there are 53.98% of students got below 81.
So first, we need to graph the question. So we have a mean of 60 and a standard deviation of 8. So we need to add it. So the second one is 68. Other one is, the first one, do this. So 68. So 68 plus 8 is 76. So 6, the other side we need to minus. So 60 minus 8, we have 52. And the other side 52. 52 minus 8 is equal to 44. So graph it first. So these are so in the question, how many percent of the student get below 72? So we need first get the value of the area over 70 in the 72. So I can say that 72 is right over here, the middle. So this 72. So here we need to get the area of below 72. Next step, we need to find the value of the z-score. So the formula for the z-score is z is equal to x minus the mean over the standard deviation. So we just distribute the value of all the given. So x is equal to 72 minus the mean 60, and the standard deviation is equal to 8. So 72 minus 60 is equal to 12 over 8. So 12 over 8 is equal to 1.5. In the z-score table, in the z table, 1.5 is equal to 0.9332. That is the area of below 1.5. So this 0 negative, this is our mean. So 0, the standard deviation is 1, so 1 plus 1 is equal to 2. Negative 1 minus negative 1 is equal to negative 2. So the bell curve is just like this. The other one is like this. So the z-score table is equal to 1.5. So just like this, the 72 is like over here. So that is 1.5. So getting the area below is equal to 0.9332, or in percent 93.32%. Just like 0.9332 times 100 is equal to 93.32%. So that's how you get the percent. So I can say that the percent of the student who got below 72 is 93.32%. So that's how to get the percent